Good afternoon, everyone. Assalamu alaikum. So we are back to our regular bi-weekly lectures, and today we have our good friend Hani Atwi from the Planetarium unit is going to talk to us about this planetary migration. So how everything, I don't know how everything is moving away from us, or I don't know how we're going to migrate to other worlds or something like that. So please, Mr. Hani, go ahead.
Assalamu alaikum wa rahmatullahi wa barakatuh. Thank you very much to be here for everyone. Inshallah, I will be in English. It's better for maybe there is Anglophone, all we know English language. Inshallah, I will be in English. If something not clear, I will go in Arabic. Inshallah, ربنا يساعد inshallah. Planetary migration. There is a scientist who make one of the theory of this planetary migration. His name is Morbidelli, I think Dr. Elias, you know him, from Nice Observatory. He said the universe is in migration status. That means everything is moving from away to another place, from location to another location. That means, and we can notice these things, that everything is in migration. But what we are talking about planetary migration, in fact, in the past 2 decades, exoplanet hunters have discovered almost 4,200, 4,100, I don't know exactly the number, planets beyond of the solar system. And there is more twice than this number potential candidate to have life. But as of known alien system, this what we name alien system, astronomers have found a substantial number of planets travel around their planets, stars, and in unusual orbit. This planet is travel in unusual orbit and inexplainable by any planetary formation mechanism. They are orbiting very close to their sun, to their stars, and this is not seen, it was seen for the first time in 1995. And it was a big question why they are here, very close to their sun. But before talking about going in deep about migration, we know all that the solar system was composed from the nebula, what we name the nebula hypothesis. It was related by Emmanuel Swedenborg, Immanuel Kant, and Pierre-Simon Laplace. They first talking about the formation of the solar system. And they said that it was composed of rotating gaseous cloud that cool and contract in the middle of to form the sun, and in the rest into disk that become the planet. This is in rapid the formation of a planet. According to the most widely accepted theory of planet formation, the solar system began roughly 4 billion years ago from a massive cloud of dust and gas as nebula. This is just to have an idea how the solar system was composed. And everything take a lot of time. But I think the last stage, which was the stage of the accretion disk, that mean between 10 to 100 million years. This type of migration happened in this area exactly. That was what the scientists found in their simulation, what we will see within a while. But in fact, the scientists, when they study the evolution of the planetary system, they found a lot of questions, difficult question to explain some phenomena in the solar system. They ask themselves, did the solar system begin with 8 or 9 planets in the origin? maybe there was 9 planets and maybe there are 10. Someone asked maybe there was 10 planets, and because there was a migration, some planets go inward to the sun and others outward to the sun, to the Kuiper Belt area. And a lot of questions still not answered. And the scientists found that planetary migration has shaped and influenced the architecture of the solar system. The solar system became as it is, as you can see in the image now. It takes time, a lot of time, to be stable, to be in this beautiful shape. All that came from what we name the planetary migration. Reason to talk about planetary migration. Why we are talking about this thing? The scientists, when they study the protoplanetary disk, they study the dynamic of this protoplanetary disk, and they found there is a lot of a lot of equation, very hard equation to resolve, to find exactly how the solar system has been shaped from this protoplanetary disk. Because in the protoplanetary disk, there is what we name the gas and the dust. Because the ionized gas interact with the magnetic field of the central gas, the dust, there was what we name the collision and the clamping between the dust and the gas. And all this make what we name the turbulence in the disk. This is the first thing. There is a turbulence in the disk happened when the solar system start to take a shape, take place in this protoplanetary disk. Second, some planets move inward to their suns, and what will prevent them falling? The scientists, they ask themselves, some planets, if they move inward to their sun, what will prevent them from falling into the star? Some bodies possess extreme comet-like eccentricity, like Pluto. Some planets are what we name the rogue planets that orbit no star. And some scientists, they give a name for this rogue planet, sub-brown dwarf, as CHA 11093, which was discovered in 2004 by Spitzer telescope, and it lies on 520 light years away from the Earth. This is what we name the rogue planet, the errant planet. And before also that, all the planets have had a circular orbits before to take oval orbit, what we name now the oval orbit, which we know all. And they found also that Neptune is smaller than Uranus in size, but Neptune more massive than Uranus, because Neptune has a core of iron and nickel, while Uranus has core of water and ammonia and other volatile gases. Uranus is tilting now in, I think, 74 degrees. It turning not like this in its side. The scientists, they give maybe a theory. They said some planet, they hit this planet, and now it came to the side. It turning to the side. Neptune has a moon orbit contour-wise, clockwise. No moon or atmosphere for Mercury. No moon and thick atmosphere for Venus. A small size of Mars. Now, when we are looking to the solar system, we found that starting from Mercury is small. After that became Venus, bigger than Mercury, and after that the Earth. But when we reach Mars, we found that Mars is small. Why it is small? This now what the scientists now they ask themselves. And maybe the planetary migration theory that will resolve this problem. We know all that till now we have discovered 4,116 to 4,200 exoplanet till now, till this. And someone are Neptune-like, gas giant, super Earth, tertiary, and unknown as what we name the rock planet. But the first idea about planetary migration started in 1995, when the scientists, they discovered 51 Pegasi P. Why B? Because it's turning around its a star, 51 Pegasi A. And B, it means the planet which is turning around the star. This planet, Pegasi B, lied about 50 light years from the Earth in the constellation of Pegasus. It was discovered in 1995 by some astronomer, Swiss astronomer. This planet, Pegasi B, is very close to the star. It's turning on 4 days only and has a mass at least half of Jupiter. And it receives heat from its sun, which reach 1,200 degrees. It's something dangerous and something very mysterious also. And this, it was not compatible with theory of planet formation and resulted in discussion of a planetary migration. That's why the scientists now, they start to talk about the planetary migration. This kind of a planet, we name this kind of planet hot Jupiters because it's very close to the mass of Jupiter and as massive as Jupiter. And the problem also, it's the orbit of this planet is very close to their sun. How can a planet like Jupiter, very massive, can be very close to its sun and has a very close orbit like Mercury? It's something strange. Why we accept this theory of planetary migration? Reason widely accepted now by migration has shaped and influenced the architecture of the solar system as we know now. The dynamic past of the planetary as protoplanetary explain the existence and the property of several solar system entirety. Our planetary system might not be as unique as we thought now. The equation of such a system are extremely difficult to analyze. That's why we have to find a theory to explain all these questions. We have 3 ways to understand the planetary migration. 3 ways. First way is a gas-driven process in which the planetary disk effectively push or pull the planet to a new position. That can explain why, for example, 51 Pegasi is located closer to its sun. Second, a result of gravitational interaction. The scientists, they said in the protoplanetary, there was a huge gravitational interaction between neighboring bodies. That means large bodies can scatter a small one, create an equal and opposite resulting force, and it's back onto itself. That means he hit the planet go inward and he go outward. This is the reaction of Newton law. Another gravitational effect, the tidal forces between the stars and the planet and tend to result in more circular orbit. That's why they say maybe all the planets before they has a circular orbit before it come as an oval orbit now. Now here, this is a computer simulation of this migration. First one, as I tell you, as the gas-driven, and it's we can say that this type of migration, which named type 1, it's applied on the low mass planet. That means less than 10 Earth masses. The orbit of this planet disturb little the protoplanetary disk and produce what we name the spiral density in the protoplanetary disk. Some imbalance occurs between the force of interaction with the spiral inside and outside. And this make an angular motion. If there is a momentum, a lost momentum occurs, the migration go inward. If the momentum was high, the migration go outward. That means the planet go outward. The second type of migration is it's type 2, at what we name gravitational scattering. And this applied on the high mass planet, greater than 10 mass of the Earth. And this can create what we name a gap in the protoplanetary disk. And still a net inward drag. That means that the planets it go inward to its star. So the planet would gradually move inward because of this disturbing in the protoplanetary disk. The third type of planetary disk is what we name the runaway migration or al-hijra al-jamiha. This also can apply on the huge, very huge planets. And here we have a strong gas-driven migration, in sometimes referred to as what we name runaway migration. But this type of migration happened in a very, it happened quickly, very rapidly draw in the planet, because the planet turn in few 10 orbit, it make few 10 orbits to go to inward to its sun. While the type 1, it take a lot of time to the planet to reach its sun. But the type 3, it's the opposite, completely opposite. It happened in 10 orbit. In 10 orbit, that means it turning very quick to go really to its close to the sun. This may explain why many Jupiter-type planets are found so close to their star. But it doesn't explain why our system, solar system, has all of its large planet far away from the sun. We know that Jupiter, Saturn, Uranus, Neptune, all they are away from the sun. But it's not really what the case of the what we name the Jupiter, the hot Jupiters. This was really tricky, because it's likely due to strong interaction between the large planet. This is why we found really the planet, our planet, very far from the sun. We have two types of migration, the theory of migration. We have Nice model, Nice, that means the observatory of Nice in France, and what we name the Grand TAC. The first one is outward migration, that means the planet go outside from the sun. And the second one is inward migration, the planet go toward to the sun. But I will talk before first nice model, because it was proposed by Morbidelli in 2004, and the other one in 2011. This is very recent. It's not very far. If you are searching on the internet, you will find that someone they give a name for the Grand TAC al-Musmar al-Kabir in Arabic. That means then the big nail, which has no sense. This the real translation is نموذج التغير الاتجاه. تغير الاتجاه, that means the planet he go inward and after he came back again. This is what the real المسمار الكبير, then the big nail doesn't make sense. But you know, we can find a lot of things on the internet. That's why I put here in red المسمار الكبير. This now I'm talking about a nice model, this outward migration, as I tell you, and it happened in 500 million years later. You see here that Jupiter was roughly at 5.5 AU, astronomical unit. Its kind of distance now at 5.2, but it was before at 5.5. When it entered in a resonance, that means he became close to Saturn, and there was a resonance between them. That means when Jupiter turned one time around its sun, Saturn turned 2 times. This resonance drove Neptune initially closer to than Uranus. That means Neptune, he was before Uranus in the beginning, and this type of migration, this type of resonance, push Neptune away from Uranus to the edge of the solar system. And now really we find that Uranus is a 19 point AU now, but it was before 17 AU in the edge, which pushed Uranus and Neptune outward to the solar system. This process scattered much of the remaining protoplanetary material out of the farthest reach of the solar system. This model can explain much of the features we can see now in the modern solar system. It could also explain the Oort cloud, why Oort cloud is here. Because when you see this this picture here, you find two lines here, two lines. These two lines between Saturn and Neptune, what we name this the icy limit. That means here there was a lot of ice, lot of big bodies of ice, and when the planet is go outward or inward the solar system, he take with us some material from this icy disk, what we name the icy disk here. And this is why we found in the Kuiper belt some icy disk, and why we found in the asteroid belt some object, some like Ceres. It's very full icy. What he is making here? Why he is here? If you are looking for the asteroid belt, we found that the shape of this asteroid belt it's irregular, but Ceres is really irregular, like the Earth, like the Moon. What he is doing here? The scientists they said that he came from this area, the icy disk, in the beginning of the protoplanetary disk. That's why now we have NICE Model 1 and NICE Model 2. The scientists, when they make the simulation for NICE 1, they discovered that the process scattered much of the remaining protoplanetary material out of the farthest reach of the solar system, create an unstable system. That means the resonance 1 to 2 make the solar system as unstable, something unstable, and this according to the simulation. The simulation found that 1 to 2 make an unstable solar system. But when Morbidelli they proposed another model, which is NICE Model 2, he make simulation 2 to 3. That means Jupiter turned 2 times, Saturn turned 3 times in this, as you see here in the in this picture, GIF picture. And he found that this kind of simulation make a stable inner solar system. That means the solar system became stable with this 2 to 3. That's why he changed the first model, NICE 1, and he take the NICE 2. Because he say that there is an what we name gradual scattering of planetary body caused by 2 gas giant to trapped 3 to 2 orbital resonance, not in 2 to 1, allowing this type of interact to make a stable inner solar system. Now, what's the advantage of this this model, NICE model? Why the planet? First one, why the planet? They explain, this model explain why the planet are in this present orbit now, in what we, that means the solar system, what we are seeing now. And this also has a relation of cozy mechanism, which make the we said that the planet before it has a circular orbit, but now with the mechanism of COSY, this a scientist, this type of migration create what we name the eccentricity, and this makes the shape of the planet oval, not circular. And still some one are circular, but the majority of the orbit became oval. This model can give an explanation of this first point. Second point, existence of small object in the solar system. There is a small, example, Ceres. Intense bombardment of impact after the planet formed. Why we know now we can see a lot of bombardment on the moon. The scientists, they say in this period of migration, the bombardment of the moon happened in this migration. That's why we found a lot of craters on the moon. This is the cause what a nice model give us to explain this strange things. Large gas planet in our solar system were migration outward. That means this explains that why some planet go outward the solar system. This caused also collision and the drastically effect of asteroid object in the Kuiper region beyond Neptune orbit also. There was a very huge collision. And as I tell you, Ceres reached in water origin from the icy belt, which it was in the start of the in the origin protoplanetary. It was there, and this object Ceres, he came with from there with Jupiter. Maybe he take us from there and he put it in the place now where we find it in the asteroid belt. Now we will talk about the Grand TAC, نموذج تغير الاتجاه. The Grand TAC, they said the first step, there was an inward migration between Jupiter, Saturn during their growth in the protoplanetary disk. And Jupiter, he was in 5.5 AU and he migrated to 1.5 AU. In the place of Jupiter, of Mars now. In that time, there was no Mars because on the sky, we get only Jupiter, Mars, Jupiter, Saturn, Uranus, and Neptune. That means the giant star, the giant object domain the sky. There was no rocky planets in that way. And when Jupiter he reached this point, there was a resonance between him, between Jupiter and Saturn, okay, and he came back out of the solar system. He sent Neptune away to the edge of the solar system, and Neptune also he takes some material from the place where Mars was and came again to 5.3 AU, where we 5.2, where its current orbit now. And after that, when Mars was formed, there was not enough material to take the shape, to come bigger than the Earth. That's why the Mars now it's became small because of the migration of Jupiter. He go to 1.5 and he came back to 5.2. And in the two case, in the two way, he take with him material when he go inward, and when he came back outward, he go also some material from the place where Mars was formed, where we get it now 1.5 AU. Now the outward migration of Jupiter and Saturn continued until they reached a zero torque configuration with a flared disk. The gas disk dissipated and is supposed to end with Jupiter near its current orbital. This is what we name now. Of course, that take a lot of time to make to reach the finally mechanism of the migration of planet, as we see in this picture. That's why the scientists say the planet starting from some origin place, and it may migrate inward and outward. That means there is no place fixed for any planet, and all the planet, which the exoplanet, which we get it now, which we find it now, close to their sun, maybe they are in migration. They are here now, and they will continue their way to another location. Maybe Pegasi 51 Pegasi B is now in migration. He is here, and he was formed in another place. He is coming now to very close to its sun, and he will continue the migration. Now, this is what we briefing about what we are talking about. Why we are talking about planetary migration? Because a planet can migrate within the solar nebula for a variety of reasons. Gravitational interaction with the gas dusk, important for hot Jupiter. Gravitational interaction with the smaller planetesimal. Near collision between large planet. Migration may have played a role in determining planetary orbit in the outer solar system. This is what we name NIS model. And a key avenue in inquiry comes from the moon. Why we found also the moon is full of crater now. And that's all. Thank you very much.
Thank you very much, Hani, for this lecture. So for this information about migration, inward, outward, and so on. So just a very quick question. So this happened, I believe, just after the formation of the sun and the planets were getting all together. All this accreting material was getting together to form the planets.
No,
yes, say that Jupiter was at 1.5 EU. 1.5 EU is Mars location now. So
yes, this is after the in this area. I will show you exactly where the scientists here, they said it happened in this 1, 2, 3 between 10 to 100 million years. This area before it coming as we know now.
Yeah.
what here I write تطور القرص الكوكبي نظام كوكبي على مدى 10 إلى 100 مليون سنة. In this area, in this period, the migration happened. This is according to the simulation do it by Morbidelli and another scientist.
Planets were not fully formed yet.
Yes. And I was surprised to when I read about this theory that Jupiter, it was 5.5 AU, and he migrated to 5.1. Yes, 5.1, where Mars is now, and he came back to 5.2. And this can explain. I was surprised when this convinced me to know that Mars is small because this type of migration. Because Jupiter, he take a lot of things, a lot of material from the place where Mars there, and unfortunately, Mars, it was smaller than we know now. And I forget to say something that the scientists, they say, thank you for Saturn to be here, because if Saturn was not here, Jupiter have been still its migration to the closer to the sun, where we find now, for example, Pegasi 51 Pegasi B, it's close to the sun. But Saturn was here, and this type of resonance prevent Jupiter to go inward, more closer to the sun. He came back away to its place. 5.2 now, as we know where it is now. And thanks for Saturn, he was here.
Any other question, please? Please, Asil, go ahead.
I just wanted to ask if if Jupiter would have migrated closer to the Sun, how would that have affected the orbit of other planets?
If what? If Jupiter, he was closer to the sun?
Yeah,
Yeah,
if it did migrate to the sun, were the other planets affected in terms of their orbit?
Of course. Maybe he will take the other planet. The solar system will not be as we know now. Maybe it will be another things in another shape. It will take another orbit also. Maybe the Earth will not be here because Jupiter, he make what we name a balance in the solar system. Balance. If Jupiter is not here, the solar system maybe will not be here. That means this kind of planet Jupiter is very huge, and he is in the middle of the solar system. And if it is not here, the solar system maybe will not be formed as it is now. Because he is make a balance for the solar system.
what do you
And
mean
also,
with balance and stable?
yes, he make a balance. But before there was
No.
in
I
the
mean, what do you mean
yes.
when you say the solar system should be stable and balanced?
Yes, because when we make the simulation, if you go to the simulation for NIS model 1, he make a simulation for 1 to 2. That means a resonance between Jupiter and Saturn. When Jupiter turn one time around the sun, Saturn turn two times. And this make what we name the resonance, which make some unbalance in the solar system. That means there was a disruption in the orbit. The planet before the scientists, they say the planet have had a circular orbit, and this migration make the orbit more flatter, from circular to be oval. And that's why we can see now some planet has circular orbit like Earth, and like Mars also, semicircular if you want. But other planet has a shape of oval, full oval orbit. And this was happened in the beginning age of the solar system, in the beginning age of the protoplanetary disk, this type of this unstable. And when Morbidelli he made the next simulation 3 to 2, he found that the solar system can be in balance now. That means that everything is in balance, everything is turning in its place. There is no big collision between the planets. Everything is in order now. But before it was not in order. This is the simulation. This is the simulation tell us these things. And if Jupiter was not here, it was more than closer to its sun, you will see something different in the solar system. Maybe the Earth will not be here now. It will be, and maybe the other planet, maybe Saturn will be closer than its distance now. That means the solar system will be in another shape.
Okay, and can you say that the mass of the star that the planet is orbiting, does it affect the migration of the planet, or just the mass of the planet?
Of course, it affects the mass of the planet also, because there is an interaction between them, between the star and the orbit and the planet also. They in the beginning of the formation of the solar system, there was an interaction between the sun and the closer planet. That means the planet, they take material from the sun, and the sun take material from the planet, and there was in disorder, what we need disorder shape in this protoplanetary disk. It take a lot of time to everything take its place. Of course, every time there is a interaction between two objects. And the story of the solar system till now is not it's all a theory. Maybe we will have another theory in the next year. This is now the NIS model 1 and 2 and Grand TAC. It's not very far. It's just from 2004, 2011, and very recent for us as in an astronomical way. Or I take it's very recent, just 10 years now, and maybe we will see, we will discover something different in the next year, inshallah.
Okay, any other question, please? Okay, thank you very much, Mr. Hani, for this beautiful lecture about migration of planets inward and world. So thank you very much. So this is, I believe, our pre-last lecture. There is also another lecture in about 2 weeks' time, and we're going to advertise for it on due time, inshallah. So thank you very much. Thank you, Hani. Thank you, Ahmed. Thank you, Isa, for setting up the Zoom connection, the YouTube connection, inshallah. So see you in about 2 weeks' time. Thank you very much.
Assalamu alaikum. Thank you very much.
Assalamu alaikum.
شكرا أخي محمد. أحسنت.
الله يبارك فيك. السلام عليكم.